here as fellow mathematician and large result.
I am tired. So let's get through this. Oh, man. Go ahead, go. Right, geometric progression now. Okay. Hey, come on. So geometric progression, same deal as our method, except this time we are multiplying by a number. So for example, we have 5, 10, 20, etc. So here in this example, what am I multiplying by?
2 each time.
2. Right? Each time I multiply by 2. Again, it's the same letter. We start with A. But we multiply, we say, by OR. So we have A OR squared, A OR cubed, etc. The A is called the first term, and the OR is called, very good, common ratio. Notice, first term is A, second term is A OR, third term is A OR squared. So what can you see about the power? It's always one less than the term number. So our formula is UN. Yep. That's it. So let's have a look at some examples with that formula now. Okay. So first example, like in arithmetic, I want, this is 1A, I want the A and the OR. So what is the A here, Joshua? What is the A here? 7, okay. And what's the OR?
Minus 2.
-2. If you're not sure how to get the OR, one way you can do it is just take this number and divide it by that number. Okay, let's go on to the next example. You need the A and the OR for the formulas, just like you need the A and the D for the arithmetic formulas. Okay. Example now. So I want the nth term. So what does A equal? 10, and OR? 2. So the nth term is A or n minus 1. Now we can clean this up a little bit. You don't need to do this, but I'll do it here. We will spend some time on powers after the break, but all you really need to know for today is when you have powers of this form, that is the same as 2n over 2, 1. Okay? We will spend an hour, 2 hours on powers, so don't worry about not knowing that. We will spend time on that later, but for today you just need to know when the power is n minus 1, that is the same as 2n over 2, 1. That's good because the 10 and the 2 cancel to make 5. Yeah. Hey, focus. 10 over 2, 5. So it's 5 times 2 to the n. That's the nth term. So we can check. If I put n equals 1, what do I have? 5 multiplied 2, which is 10. If I put n is 2, what's 2 squared? 4 times 5. So you see I have 20. And if I put n is 3, I have 8 times 5, which is 40. No, what's your question? Okay. Shall I continue or what?
Yes.
Yeah? I'll do the next one, will I? I'll go on to number 3, 3a. Okay, 3a now. So in 3a, it's the same problem as last time. You don't know how many terms there are. What did we do in the arithmetic lesson for finding how many terms there are?
We made the last term.
We made the last term equal to un. We do the same thing here. Un equals minus 256. What's the formula for un? A or n minus 1 equals minus 256. What's A? And or? 2. Yeah. We can use our little trick again. So we have 2n over 2, 1 multiply minus 2 equals minus 256. So I should take this. Oh, well, in fact, that cancels that, doesn't it? And the minus cancels the minus here. So you're left with 2n equals 256. Splitting the n minus 1 into 2n over 2, 1. Now, if you remember from the lesson on surds, we had a look at the prime factor tree. Yes, you have that. 2, 5, look. No, just look up here for a moment. Look up here. Look up. 256. Okay. You can say that is 2 times 128, which is 2 times 64, 2 times 32, 2 times 16, 2 times 8. No, you don't. I'm showing you how to get the answer, because I'm going to write the answer down directly. Someone's going to say, Mr. Stephen, how did you get that number? So I'm showing you before they ask me. 2, 4, 2, and 2. How many 2's are there? 1, 2, 3, 4, 5, 6, 7, 8. So this is 2 power 8. So here I say 2n equals 2 power 8. So what does n equal? 8. So, Mr. Stephen, how did you say 256 is equal to 2 power 8? I used the tree I did in the lesson on surds. Okay?
Can we do it with look?
Yes. Or if you just knew it already, you can write it down. Yes.
Is there any other way?
Yes, but this is all I'm going to show you for today. Okay. Huh? Okay, I'm going to go on to the next one now. 4. You remember doing that in surds? Yeah. Okay, 4a. The fifth term is minus 16. And the sixth term is minus 32. You know what, actually, I'm going to change that one to one that's a bit more difficult. I'm going to do C instead. 4C. The third term is 8. And the eighth term is 256. Just like the arithmetic, it is enough to be told 2 pieces of information. And from this you can find the A and the OR. You know that the third term is 8. Therefore, A OR squared equals 8. And the seventh term is 256. What's the formula for the seventh term? AR7 equals 256. So here you get that means this. Now, the physics students have seen how to solve something like this, and you know how to do this from maths class. You could use substitution method. You could find what letter? A. You could find A from the first and put it into the second. So what does A equal from the first? 256 over r power 7. But there is another way to do it which I prefer. We can add or subtract equations in the elimination method. Remember, elimination method, we add or subtract. You can also multiply or divide. So we will divide these equations. A divided by A, 1. Or 7 divided by r squared, or 5. And then 256 divided by 8,
32.
32. So R5, 2, 4, 8, 16, 2 power 6, is it? Sorry. No, actually, I don't even need to do that. So I have R power 5 equals 32. So that means R equals the fifth root of 32, which is on your calculator, the fifth root. So R is 2. Right, focus for a second. I want to find A now, so I use substitution. Which formula should I substitute it into? This one here. So I get A equals 8 over r squared, which is 8 over 4, is also 2. So A equals 2 and r equals 2 here. And pause. Okay, I'm going to scroll down now. So what we've done is we've done the examples that need the UN formula. So just like in the arithmetic progression lesson, we'll now go to find a formula for Sn, the sum. So at the start we gave as an example 5, 10, 20 as an arithmetic sequence. I'll add them together to make a geometric sequence. Now I have a geometric series. So we want to find a formula to add these numbers together quickly. So, just like the proof for the previous lesson, we start off by saying Sn equals A plus AR plus, what's next? AR squared. And what is the last term? N minus 1. Now, for this proof, what we do is we write down what is or multiply Sn. So, A and AR squared, you multiply all of them by or. So what's first? AR, and next? AR squared. AR cubed, etc. And then at the end we have AR N. Now, how did I get N? Well, if you think about it, A or N minus 1, what does that equal? A or N over r power 1. And what am I doing? I'm multiplying by. So when I multiply here, they cancel. So that's why at the end I have AR. Now, what I do next is I subtract the two lines. I do a minus here. So I have Sn minus or Sn. Now notice what happens. A just stays as A. That's fine. But you have AR minus AR. So they cancel each other. You have AR squared minus AR squared. They cancel each other. You'll have AR cubed minus AR cubed. They cancel. It'll cancel, leaving only the last term and the first term. Everything else has cancelled. So we have A minus ARN. What was I looking for? Sn. So on the left I have Sn times 1 minus or. What's the verb? What verb? What did I do here? What's the verb? Factorize. And factorize here, A times 1 minus Rn. So I just need to divide by 1 minus or and I get my formula. Sn equals A 1 minus Rn over 1 minus or. Now, there is only one situation this formula does not work. Or must not equal 1. Now, wait. Someone will be thinking, and someone will be going to ask me, Stephen, in my high school maths book there were 2 formulas. One formula that I use when or is more than 1, and one formula that I use when or is less than 1. Is anyone thinking of that?
No.
Not really sure.
It's a stupid question.
No, one person was. No, because if you go to an Irish high school maths book, it will say this. Anyone? Yeah. Anyways, no. There is only one formula here. Yes? Right, shh. Say again?
You need to write something.
You could from this one, yeah. Which is a separate lesson. Now, if you take out your high school maths book or a maths book from the library, they possibly will give you 2 formulas. They will say, use this formula if or is more than 1, or use this formula if or is less than 1. Not necessary. I don't know why they do this. It's the same answer. There is only one formula here, not 2. So if you see 2 in a maths book, that's a mistake. It's a mistake, yeah. No, it's an unnecessary. It's unnecessary, okay? All you need to know is this formula always works as long as or is not 1. Okay. So let's look at some examples of using this formula. Did you write it down? Yeah. Okay, so for example, 5a. I want to calculate S6, which is 1 plus 2 plus 4 all the way up to 32. Okay, what's the A here? And the or? 2. And the N? No. 6. So the answer is S6 will equal, and the formula's right there, A times 1 minus or N over 1 minus or. So it's A, it says it here, 6 terms. 1 minus or over 1 minus or power N. So we have what in total, please? Sorry, I have it upside down, don't I? Yeah. Sorry, the 6 is up here. So what do I get here? 63. 63. Okay. Now we'll do an example where you don't know how many terms there are. So there are n terms. So this is like example 6a. You have minus 1 plus 1 minus 1 plus 1, etc. What's the a here?
Minus
And the or? Minus 1. And the n? We don't know. So the formula is Sn equals a 1 minus or power n over 1 minus or. That will be minus 1 over 1 minus minus 1n all over 2, isn't it? Yeah. So we get Sn equals minus 1 power n minus 1 all over 2 is the answer. But this is the start of the question. So, you notice that this one's kind of interesting. If I put n equals 1, what should the answer be? It should be minus 1. If I put n equals 2, what should the answer be? If you look at the top, very top. If I add the first two numbers together, what do I get? 0. If I add the first three numbers together, what should I get? Minus 1. If I add the first four numbers together, what should I get? 0. Because it's going plus 1, minus 1, plus 1, minus 1. So if you take out your calculator and you put in, like, for example, 4, make sure that you get 0. Well, I don't even need the calculator because you can see here, minus 1 power 4, what's that? 1. And 1 minus 1? 0. Okay? So you can see, again, this lets you add up many terms together. This lets you add up many terms together.
So this is the final answer.
Final answer, yeah. Yeah.
But we still
No, that's it. Because they'll also do this in the exam. They will say, find the nth term, or the nth sum. And they won't tell you the n. They want n in the answer. So yes, no, this is the answer. Yeah. Find the equation, the formula. Okay. Can I scroll down now? What's the question? Sit up.
What's the question?
It's which one did I say? 6a. Now I'll do 7a. 7a now.
It's actually not.
7a, I have minus 1, minus 3, minus 9, etc. to minus 7 to 9. Okay, what's the a here? Minus 1. And the or? 3. And the n? We don't know. How do we find out how many terms there are? Yes. You notice that there's a pattern repeated. Yes. So we use the formula un. Un equals minus 7 to 9. So we have a or n minus 1 equals minus 7 to 9. So a is minus 1, and then this will be 3 n over 3 1 minus 7 to 9. Okay, I can cancel my minuses and bring my 3 up to the right. Cancel, cancel, bring it over here. What's 729 multiplied by 3, please? 2187. Okay. Three power 10. Too big. 3 power 8. 3 power 7, is it? 3 squared, or log, yeah, but I haven't taught you that yet. So pretend you don't know it. 3 power 7 is this number here. You can use the 3 to find it. 3n will equal 37, so then n will equal 7. Although I know some people already know about log and other things. You can use that to find the n if you want.
With the logs.
Yeah,
We don't talk about these things.
not yet anyways. Okay, so now 8a. So now it starts to get quite difficult. Come on, Tanish. So 8a. 8a. What? 8a. I tell you, the 9th term is minus 6561. And the sum of the first 2 terms is 2. And it's geometric again, of course. So we want to find the A and the OR. Okay, so we know the 9th term is minus 6561. So this means A or power 8 equals minus 6561. And then here we have A 1 minus OR squared over 1 minus OR. What should that equal? It should equal 2.
We can divide by 1 by 9. Or substitute a.
Yeah, but that's something I have to show you first. Now, this system is quite difficult to solve, so watch carefully. What we should do, we should keep the first one the same. A or 8 equals minus 6561. Here, we should do long division to simplify it. When you do long division here to simplify it, and then multiply your answer by A, you'll be left with A plus A OR. Now that should not be a surprise, because what does S2 represent? The sum of the first 2 terms, which is exactly A plus A OR. Yep. Now, here, like somebody said, maybe we could use substitution. So here we have A, and here we have, we could get A as well. We could put the first into the second. But I think here I can clean this up a little bit. I think it would be better actually to leave it as A times 1 minus OR equals 2. Or we can just do our division.
1 plus,
Sorry, 1 plus OR. We could do our division. I will go for division. But like I said, in the arithmetic lesson, you could use substitution if you want. But I think division is handy here. So dividing, A over A, they cancel. OR power 8 over 1 plus OR, that equals, what's this? Oh, this doesn't divide, does it? So we get minus 6561 over 2. So, just like what you learned in week number 1 and what you've learned in chemistry, I'm sure, we cross multiply. So we get 2 or 8 equals minus 6561 times 1 plus OR. Expand, 2 or 8 equals minus 6561 minus 6561 OR. Bring to the left, 2 or 8 plus 6561 OR plus 6561 equal 0. Yeah?
Did we take out that?
No, because it's not in everything.
Wow. if you take out R, we will find the two possible values for R.
How would you take R out?
Factorize R.
But this is not quadratic.
Yeah, but we can take out R.
No, I don't think you can turn this into a quadratic.
No, not into a quadratic.
Oh, you mean factor it out?
Yeah, then we'll have R equals 0 or
You could.
power 7, or when it will be easier to solve.
You would need your R's to multiply to make R 8. And you need an R in the middle. It might be a bit tricky. Try it. You just see what you get. Yep.
Shouldn't we like this plus like 6561 plus R?
Huh? No, this is right, isn't it? Yep.
Why not?
Change the or. Oh, for the for which is 6561? Oh yeah, you can change that to 3 power 8. Yeah. Anyways, hang on, we're getting off track here. So this is the equation I need to solve for or. Now it's not quite a quadratic because of the or 8. It's not quite a cubic because the or power 3. What is wrong? Nothing? Everything's okay? But you can solve this type of equation using the same method that you use for cubics, which is first you should find a root, and then after you find the root, what do? You divide it. Okay? So I would like people to try different values of or now to see which value makes this 0. Now I can tell you, don't bother trying or is 0. Right? And don't bother trying or equals 1, because remember we said or can't equal 1. Don't bother trying positive 2, because we don't have any minuses. So the first number you should try is minus 2. So try minus 2, please. It's positive 3 will do it, will it?
No, negative.
It's going to have to be a negative or. So is it?
Yeah, negative 3.
Negative 3, okay. So what you do, you try, now look up here. You can work, no, that's okay.
Before that, he can't do anything
That's
else
okay.
before he understands.
You can work together when you have time. Come on, focus here. So firstly, we try or equals minus 2. And did we get 0? No. Then we move on to try or equals minus 3. And then did we get 0? Yes. So that, what's wrong?
Sure, actually we don't need to make quadratic because the 1 plus r is minus 2.
The 1 plus r.
Is minus 2 because r power 8 is impossible to minus. So
Oh, you can see it from the top, is it?
Yeah.
Good for you. Yes, congratulations to you. I'm going to continue it this way, but you're able to see what the value must be from just looking at the one at the top. Good. Or power, come on, continue explaining. Yeah? Don't be shy. Everybody's listening.
No pressure.
No pressure.
It's the r power 8.
For
is
goodness
possible
sake.
to be
Charles, get it. Joshua, you two. No, hang on, I'm not continuing. I want the two of you out now. Get moving. I'm tired of looking at the back there. Now, hang on, I'm not in a good mood. So be quiet unless you want to be next. Charles, get out now. I'm not going to wait for you. Hurry up. And wait outside the room. I want to talk to you at the end as well. Okay, go ahead there. What were you saying? So, at the top, yes.
I see that the top is that the r power 8 is impossible to minus the value of negative value.
Yes.
So the minus put the bottom, the minus 2. And then 1 plus r equal minus 2 is the r equal minus 3. And then put the minus 3 for r, then you can get the 6, 5, 6, 1.
Now, I'm sure most people here found that too difficult.
I understand.
But she's right. This isn't the only way to do it. The reason I'm doing it this way is because it will always work for you. Okay? But you could have stopped earlier if you could see from the beginning what the OR should be. Now, if you're shaking your head going, no way, Stephen, that's ridiculous. Fine. But you'll need to continue it down to here. Okay?
Do we have to like guess which one? I mean,
Yeah, but don't worry.
I solved it without guessing.
Yeah, no, that's fine too. There's many approaches to take here. I'm just trying to relate it to a method that you've seen earlier.
Okay, we'll be happy with guessing.
Yes.
That's not really scientific.
For this cubic and higher powers is what you have to do in this case. Yes.
But we have the method.
Because in fact, R power 8 equations don't have formula solutions.
But we have a magic button here.
Yeah, but what does that do?
In fact, you put the number 6561. You press shift and fact, and you get 3 to the power of 8.
Oh yeah, that's fine. Yeah, you can use that. Yeah, I've no problem with that.
How do you do it?
No. Later. He'll show you later. Okay, so here we have R equals minus 3. Now, I will cut this short now. What we would normally do here when we did our cubic is we change this into a factor. What would the factor be? Yes? R plus 3. Right? Now, R plus 3, you would then, what do you do with it? Divide it inside. But you don't have to do this here, because I'm going to tell you a fact about these problems. They actually only ever have one solution. There is only one answer. So when you divide it in, you make an equation. This equation doesn't have any solutions. Okay? So there's no point in doing the long division, because the answer you get from the long division, that equation doesn't have solutions. Or it doesn't have any solutions you can use. Okay? So in fact, as soon as you get the answer from guessing, that is the answer. Because you're wasting your time if you try to find more answers. There should only be one answer anyways. And the fact that you found one answer means you can stop. There's not multiple answers here. There's only one answer.
Always.
Let me think about that carefully before I commit to saying always. This is number 8. Mostly always. There's the only exception I can think to that is that you might get a plus minus. Okay, so apart from plus minus possibilities, there's really only one number answer. Okay, but there's no minus here. I mean, if you use plus 3, does that equal 0? No. So there's no positive answer here. Okay, so now that we have the OR, how can I find the A? I sub it back in. I should use this one here. So A equals 2 over 1 plus OR. Can someone type that in, please? 2 over 1 plus OR. Works out as minus 1. Okay. So we have the A and we have the OR now. Yes? Yes, we can. Which I think was the point Dana was making too. Yeah. You can discuss it with her after class. Yes? Okay, so now the last type of question, 9a. Yeah. I tell you in this question that these 3 terms are in geometric progression. Yes? Now, again, we need to find the value of x that makes them have a geometric progression. So, for example, if I make x 0, what are my numbers? 3 minus 4, 4. Is that geometric progression? No. what do we know about geometric progression? When I take this number and multiply it by or, I get that number. And I take this and multiply it by or, I get the next number. Therefore, if I take this number and divide it by the first number, I should get or. So I have or equals minus 4x minus 4 over minus 2x plus 3. And also or equals minus 8x plus 4 over minus 4x minus 4.
It's actually minus 8x.
Sorry, which one is it? Minus 8x minus 4. Thank you. So just change this here to minus. So here is minus. Now what do I do with these two equations? Make them equal. So I get minus 4x minus 4 over minus 2x plus 3 equals minus 8x minus 4 over minus 4x minus 4. Does that type of problem look familiar? Yes. If you go to the second worksheet in your book. Second worksheet, page 4. Look at the last 3 questions. Have a look at them now. You see you've done this type of problem already.
Just equate them and cross multiplication.
Yes, yes. Yep. Do you see that? You've done that type of problem already. So I will not finish this. Now, I want you working on these for a few minutes. I want you to, your homework is the last 2 again in each. Now, work on these for a few minutes. And